to Unit 4, Extending Decimals.
This is Mr. Valentine, and in this unit we will be discussing place value
through the thousands. For this lesson, students are introduced to the thousands place. They are expected to use expanded notation and numerals to represent the value of a decimal through the thousands and round decimals to the tenths or hundredths place. So let's take a look at the place value chart. Okay? In previous grades, students discussed the tenths place as well as the hundredths place. Today we'll be discussing the thousands place. All right? So,
Ms. Valentine?
let's talk about the representations. We're going to start with forms of representation. Students are expected to use expanded form, which is the representation of a number as a sum of its place value. Mr. Valentine is going to show us an example.
So we have the numbers 761 and 823 thousandths. As Ms. Holland did state, that this shows the sum of the numbers according to their places in the number, which is their place value. So we have this first digit here, the 7, which is located in the hundreds place. So we write that out as such. The 6 is in the tens place. The 1 is in the ones place. And now we get into the little tricky part with the decimals there. That 8 is in the tens place and is represented this way. The 2 digit is in the hundreds place and is written as such. And I'm going to write the 3 digit, which is in the thousands place, which is written out as such. That is that number represented in expanded form.
Okay. And I'm going to discuss the expanded notation, which is the representation of a number as the sum of its place value as well. But in this case, each term is shown as a digit times its place value. So for expanded notation, I think about multiplication notation. So you have multiplication and addition in this one. So I'm going to expand the place value. I'm going to continue to do that. Let's start with the 7. For expanded notation, we first identify the value of that number. The place value of this number is the hundreds place. So I'm going to write 100, and then I take that place value and multiply it by the number that's in that place. So 7 times 100 will give me 700, plus the 6 is in the tens place. So I identified the place value, multiplied by 6, plus the 1 is in the ones place, multiplied by 1, plus, now we're getting into decimals, the 8 is in the tenths place, so I must first write that place value, which is the tenths place, times 8, plus the 2 is in the hundredths spot. So again, I identify the place value first and multiply it by the digit that's in that place value. Okay, last but not least, we have the 3 and the thousands place. So I'm going to write that out as it is, the place value, multiply it by 3. And this would be expanded notation.
Also, students, do realize that any places after the decimal can be represented also as a fraction. So the 8 that was in the tens place can also be shown as such. Also, this 2 that's in the hundreds place can be shown. Thank you, Ms. Holland. This way. And the 3, which is in the thousands place, can all be represented in that other way also.
Yeah, so they can see it as fractions or decimals, but in this case, mostly it will be decimals. All right, thank you. They're also expected to do standard form, which is the representation of the number using the digits itself. So it's just basically the number written out as it is.
Exactly.
In word form, it's just writing the number in written words. So exactly how you say that number, that's how you would write it. And those would be the different forms of representation
Yes, ma'am.
for that number. Students will also be required to order and compare decimals through the thousands place. Whenever we're comparing numbers, we consider the place value of the number, starting with the largest place value first. We're going to do an example of comparing two numbers. Let's see, let's take 803 and 20 thousandths. Compared to 803 what's on the side, and 200 thousandths. Now we're going to compare these two numbers. Now these numbers look alike because they have the same digits. But what we tell students to do is whenever you're comparing numbers, please line them up by the decimals. And Mr. Valentine is going to show us an example of that.
So I am going to rewrite my second number here, 803 and 200 thousandths, underneath my first number here, 803 and 20 thousandths. So now that I have those lined up, as Ms. Holland stated, we start off in our highest place value, and which when we look at our number is the hundredths place. Once we start there, we start working our way to the right of that number. As we can see, in the hundredths place, they both contain an 8. So their values are both the same, which is 800. Next, in the tens place, we have a 0 located in both of those. Those values are the same. Now, in the ones place, there are both 3s, and their values are the same. Now we get down to the point behind the decimal, which our first place is the tenths place. And here we have in our first number a 0 in the tenths place, and in our second number, a 2 in the tenths place. So our 2, which if we wrote both of these numbers out in expanded form, would look like this, and this would just be a 0. So therefore, our 2 has a higher value in that place than the 0. So these numbers right here, in this place, shows that the 2 is greater than the 0, which means that my whole number here, 803 and 200 thousandths, is greater than our other number, 803 and 20 thousandths. But let me just rewrite our number statement again so we can rewrite it in the correct way using our symbols. And I will clear this. So now I can select the appropriate symbol that's for it, written out this way, and it states that 803 and 20 thousandths is less than 803 and 200 thousandths.
Good job. And students are also expected to order numbers from least to greatest or from greatest to least. And when they do this, we also expect you to line your numbers up so you can identify by place value. Let's move on. Okay, I want to go back and review something real quickly. One misconception that we get a lot is that students confuse that when the numbers are all the way in the thousands place, when they see a bigger number, some of them think that that means that that number is greater than.
It
That's
doesn't?
not always the case. Say, for example, if we have this number, 451 thousandths compared to 6 tenths. Sometimes students would think that, oh, 451 thousandths, that's greater than 6 tenths. That is not the case. Because again, if you look at that number and you line it up by its place value, here you have 6 tenths compared to 4 tenths. So that's why we encourage you to make sure that you start with the greatest place value. Because in this case, 6 is bigger than 4. So we can put zeros here as a placeholder, and then you can look at this number as 600 thousandths compared to 451 thousandths. And that will give you a better understanding whenever you are comparing numbers or whenever you're ordering them from least to greatest.
Miss Holland, I just noted that you added some zeros to the end of that number 6 tenths. But does that change the value of that whole number?
No, it does not change the value of the number. The magnitude of that number, its relative size, is still the same. I can represent 6 tenths as 6 tenths. I can represent this number as 60 hundredths or as 600 thousandths. Even though the number looks different, it still has the same value. That 0 is just a placeholder in this case. So these numbers are equivalent.
Ooh, that's beautiful vocabulary, Miss Holland.
Okay, and students will also be expected to simplify expressions. There we go with those numerical equations again.
Oh, don't we love those, students?
Yes, we're going to come back to these number lines. All right, so let's see. Let's start with an equation. Let's take 215 and 4/10 minus 2 and 6/6,000 plus 5 and 1/10 plus 5 and 10,000. Oh, sorry, 100,000. 5 and 100,000. Let's
Sweet.
simplify that.
Well, I know from our order of operations lesson that we did a couple of units ago that I'm always going to start with my numbers in my parentheses first. So my two numbers that I have in my parentheses are 2 and 6/1000 plus 5 and 1/10. So I'm going to add these two numbers because I see an addition sign here. So I have 2 and 6/1000 plus 5 and 1/10.
And I'm glad you remember the rule about the parentheses. Parentheses always start within the parentheses.
Sweet. So as Ms. Holland stated, that I can add these zeros here and it does not change the magnitude of my number here. So now I can complete the process of my addition. So 6 plus 0 equals 6, 0 plus 0 equals 0, 1 plus 0 equals 1, and then 2 plus 5 equals 7. I do want you students to realize something that I have done here. I lined up all of my digits according to their place in their numbers. I lined up my ones with ones, my tenths with tenths, hundreds with hundreds, and thousands with thousands. We want to make sure that our numbers are always lined up. That way we're adding the appropriate values to each other. So now I know what my answer is to the number within the parentheses.
7 and 106,000.
And I'm going to erase that part right there to give me a little bit more work room, because Mr. Valentine does write a little bit big. And now I can start with my other portion of it. This is done in my parentheses. And now I have 215 and 4/10 minus 7 and 106,000 plus 5 and 100,000. Now, according to my order of operations, I can now work this from left to right because I only have addition and subtraction within it. So starting to my far left, I have 215 and 4/10 minus 7 and 106,000. Let me rewrite this so we all can see where our value should be placed. I have 215 and 4/10, and I have 7 and 106,000. Now, as stated earlier, I can add these zeros here, and it does not change the magnitude of my number, but remember, we only can do that after the decimal in those numbers there. So now I can start my subtraction process. I have 0 minus 6. I cannot do that, so I have to go down and borrow. I cannot borrow from my hundredths place neither, because that doesn't have anything in there. So I have to come all the way down to my tenths place and start the borrowing process from there. So I borrow, that becomes a 3. This is a 10 here. I have to borrow again to go here, and this is my 10 now. So now I can start. 10 minus 6 equals
4.
Oh.
9 minus 0 is
9,
3 minus 1 is
2. Oh, and look here, I come to another place here where I cannot perform the operation. I have in my ones place a 5 minus 7. So I have to borrow again. This becomes a 0, and this number becomes 15. So 15 minus 7 is 8, and I can bring down the rest of my numbers because there's nothing located underneath them. So my answer for that portion is 208 and 294 thousandths.
Now we have to add 5 and 100,000 to that.
Now, Ms. Holland, I want you to ensure that I don't make a mistake lining this up. So I'm going to start with my 5 right here underneath this 0.
No.
Okay.
The 5 is in the ones place, so you have to start it right under the ones place, which is the 8 right now.
Thank you, Miss Holland, because I want to make sure all of those numbers are definitely lined up in their correct locations. So now I can go ahead and do my addition. 4 plus 0 equals 4, 9 plus 0 equals 9, 2 plus 1 equals 3, 8 plus 5 equals what, Miss Holland?
13.
13. I knew she knew it. And then 1 plus 0, I had to carry over a 1. 1 plus 0 equals 1, and then 2 gets brought down.
So our answer is 213 and 394 thousandths. Well done. All right, and the last concept that we would like to go over is students are expected to round place value up to tenths and hundredths place. So we're going to do an example of rounding. Let's see, let's take 635 and 492 thousandths. All right, here in this case, we'll start rounding with our hundredths place. So whenever students are asked to round, okay, so first what I ask students to do is always identify that place value that is expected to be rounded. So the place value that we're expected to round to is what, Mr. Valentine?
You said to the nearest hundredths place, and the digit that's located there is in a 9.
A 9. So I'm going to underline that place value.
I got this,
So-
Miss Holland. I'm so excited about this rounding. I know. Take that 9, and since we're rounding it, it's gonna look like a spherical shape, like a circle. So round means it's gonna become a circle.
No,
Oh,
no. We are going to be rounding the number,
oh.
okay? We're not creating a round shape.
Oh.
I'm a good try. All right, so we have our hundredths place. So I tell my students to make sure that you identify that place value. In this case, we have the 9 in the hundredths place value. So the 9 is going to look at the neighbor to its right. And right now we have the 2 to the right. So the rule is 5 or more,
Raise the score.
4 or less, let it rest.
rest.
So this case, this is a 2, which is less than 5. So we're going to let this 9 rest. So therefore, our new number is going to be 635 and 49 hundredths. We do not need to write anything after that. If you do, a 0 will be fine. Some cases, I still have students writing that same digit. It's as if it was never rounded.
I don't know why.
Okay? Now, if we took this same number and was asked to round it to the nearest tenths place, it's going to look a little different. In that case, let's rewrite the number. 635 and 492 thousandths. If we take this and round it to the nearest tenths place, again, underline the place value you're expected to round, which will be
The digit 4,
digit 4. And then the 4 is going to look over to the,
9, which is in the hundredths place.
and then remembering the rule, 5 or more raises score, 4 or less give it a rest. Now in this case, this is more than 5. So I'm going to raise the 4 up to the next number, which will be 5.
Oh.
So therefore, I have 635 and 5 tenths. That will be my new number. If I did put anything behind it, it'll just be zeros. So, rounding. Do you want to try one more?
Yes, I would like to give one a try, Miss Holland, and see if I can do it.
Okay, let me give you a number real quickly. Start with a fresh one. Let's round to the nearest tenth place.
I think I got this. I'm not gonna make it a ball.
There you go.
All right, so I listened very carefully to Miss Holland, and she said the first thing I want to do is identify the place that I am rounding. So it says the tenth place. So I look at my number and I see the digit 9 is located in my tenth place. Now Miss Holland said I have to look to the right, and that will determine whether or not I round up or let my number rest. So I look over to my right, and there's the digit 8 in the hundredths place. So the digit 8 is greater than 5. 5 or more, raise the score. So I will round up with my number. But Miss Holland, what do I do with a 9?
Well, let's look at that. So we're going to have to round this up. One easy way that I show students is the 9 is going to be rounded up. The number after 9 is going to be a 10, correct?
Right.
So let's just look at this. Let's see if we do add 10 to this. It's going to look like 685 because 4 and 1 is 5. And then this is a 0.
Hot dog, Miss Holland. Oh, you got me again.
So 685 will be our new number.
Sweet.
Now, students will be expected to round. They'll be expected to identify numbers in different forms of representation, as well as compare numbers and order them from least to greatest. And basically, for Unit 4, that's summed Unit 4 up. Now, expect more in Unit 5.
Because when we get to Unit 5, guys, we're going to be multiplying and dividing decimals. This is Mr. Valentine and
Mrs. Holland, good luck.